In this video, we'll be demonstrating the experiment, which is Experiment 1, Part 1, obtaining a biphasic compound action potential. Now, each of the experiments has a methods section, which describes how to carry them out. If we scroll down, we can see the methods for this experiment. Now, the first instruction says to set the stimulus voltage to 1 volt in the stimulator panel. Now, if we scroll down a little bit further, you can see the stimulator panel here, and you set the stimulus voltage by sliding this dial up and down. I find that a little bit fiddly sometimes though, and so usually I just highlight the number in the box and then use the keypad in order to type in the value that I'm after. Next, have a look above the stimulator panel. This is the lab chart window, and this is where our response is going to appear. So now we're all ready to go. Our stimulus has been dialed up, so now all we need to do is press start, and the stimulus will be delivered to the nerve, and the response will appear on the screen. Now let me just point out a couple of features of this response so that we know what we're looking at, and then these of course will be the same for each of the experiments that we perform. Now if you have a look down here, the horizontal axis is displaying time, and that's currently being shown in seconds. The vertical axis is the response, and that's being shown in millivolts at the moment, and you can see the units up here. This lower channel now shows when the stimulus was applied to the nerve, and so you can see this little blip here, and that's the point in which the stimulus was actually applied. If we go up onto this upper channel now, the red channel, this is the actual response from the nerve. So this is the voltage being measured by the actual recording electrodes which are touching the nerve. Now you can see two deflections on this upper channel, this red channel. The first is this smaller one, which you'll notice is immediately above the point at which the stimulus occurs. And this is important, and we'll come back to that in a sec. The second deflection that you can see, though, is a much bigger one, a much broader one, and it's much more obvious at this size of stimulus that we've delivered here. And this deflection is produced by all the action potentials traveling over the recording electrodes. So in other words, this second deflection is the actual compound action potential which we're trying to see in these activities. The first deflection then, which occurs when the stimulus occurs, is what's called a stimulus artifact. Because the nerve is surrounded by a saline solution, it conducts electricity very well. And so as soon as you apply an electrical stimulus at the stimulating electrodes, that stimulus is conducted almost instantaneously down to the recording electrodes through the saline solution. And so it's detected and causes this almost immediate small deviation, small deflection. That deflection has got nothing to do with the action potentials or the axons. You would see it even if you had a wet piece of string sitting over the electrodes. And so that's why we call that the stimulus artifact. It's not the actual response of the nerve. And so to see where your actual response is, which is due to the action potentials traveling down the axons, you need to look to the right to some time after the actual application of the stimulus. And so that's what we see here in that second deflection. Now, what do we mean by a biphasic compound action potential? The nerve is sitting on two recording electrodes, and the response that we see on the screen is just the difference in charge between one recording electrode and the other recording electrode. Now, depending on your tissue and your setup, including things like how far apart your electrodes are, how many action potentials were fired, how thick the nerve is, whether there's any connective tissue there, and so on. You're going to get different responses from the nerve sitting on these recording electrodes. So sometimes you'll get really big, really obvious biphasic compound action potentials. But sometimes, like this one, you do get a second phase, and you can see that there is a deflection in the downwards direction. But sometimes, like this one here, for example, you don't get much of a response at all. I think the example data that we've uploaded for you has got a really pronounced second phase, a deflection in the downwards direction, and so that one's really noticeable as a biphasic compound action potential. But either way, the response of the axons is really individual and really depends on the tissue. So that normal biological variability is something that we really want you to take home from seeing actual experiments with actual tissue. Now that's all we wanted you to see on this page, so we just wanted to get a response onto the screen, and so I'll leave that here and we'll go over to page 4 where we'll continue on part 2 of experiment 1.